Hi everyone, this is Keshav Agarwal. So let's discuss today LeetCode daily challenge, that is pseudo-palindromic path in a binary tree. So we have a given a binary tree where node value are in the range from 1 to 9, and a path is in the binary tree is said to be pseudo-palindromic if at least one permutation of the node value in the path is a palindrome, and we have to return the number of such pseudo-palindromic path going from the root node to the leaf node. So let's discuss the given example. So we have a node 2 that is connected with node 3. One. Yeah. So first of all, let's how many paths are there? So the one path from root node to leaf node is this one. The second path is this one, and the third path is this one. There is no other path other than these three paths, right? And we have to tell how many pseudo palindromic paths are there. So let's consider first of all this path, that is 2, 3, 3. Can we permute? Is there any permutation possible which can turn this number this permutation as a palindromic basically? So yes, we can permute these numbers in such a way that the 3 to 3 is a palindrome, right? This sequence is palindrome. Let's consider this 2, 3, 1. Is there any permutation possible which can make this sequence as a palindrome? No, right? So we will not consider this as a pseudo palindromic path. And this third path, that is 2, 1, 1, we can make a sequence like 1, 2, 1, and this is palindrome, right? So how many pseudo palindromic paths are there? There are two paths, 3, 2, 3, and 1, 2. Similarly, let's consider one more example. Let's suppose 1, 2, 3, and 1, 2. So there are two paths, that there is this one and this one. One is 1, 2, 3, and you cannot make this sequence as a palindrome. It's not a pseudo palindromic path. And the another is 1, 1, 2. You can convert this to 1, 2, 1, and this is a pseudo palindromic. This is palindromic sequence. So this path is a pseudo palindromic path. So answer of this will be 1, right? So what we can do basically, uh, we can apply a DFS considering. So first of all, a sequence. How we can check if we have a sequence? How can we check that this we can convert this sequence into a palindromic sequence? So the sequence will be palindromic if the occurrence of each number is even. Like if at max one number, let's suppose frequency. Wait, let's suppose frequency of I, number of time I occur in the path, right? So we can convert a sequence, palindromic sequence, if there is at max one I such that frequency of I is odd, and for all other I, frequency of I is even. So for an example, consider this case 1, 1, 2. So frequency of 1 is 2, and frequency of 2 is 1, right? So what I said is, if there is at max one I such that frequency of I is 4. So yes, there is at max, and there is only one I, that is 2, such that frequency of 2 is 1, and for all other I the frequency is even. So it is possible. So we can convert the sequence to 1 to 1, that is palindrome, because the number which is which appear odd times, we can insert this number in the middle basically, and rest of them are palindrome, right? So let's suppose 1 1 2 2. Now this time frequency of 1 is 2, and frequency of 2 is also 2. That is also valid, right? Frequency of 2 is 2. 1 2 2 1 or 2 1 1 2. They both are valid. But let's suppose there is this path such that 1 2 3. Now all of the number has a frequency. Basically frequency of 1 is equal to 1. Frequency of 2 is equal to 1. Frequency of 3 is also equal to 1. So there are three I such that frequency of I is odd. So you cannot make this sequence as a palindromic sequence, right? So this is not a valid path. So basically this is the condition to check if we can convert a sequence to a palindromic sequence. Now how we will know the frequency of I for every path? So what we can do is, let's suppose in this scenario we will do a DFS and keeping a frequency array of size 10, right? So what we will do is basically at this we are at this node, so we will increase the frequency of 1 by 1. Then we will go to this node, increase the frequency of 3 by 1. Then we will go to this node, increase the frequency of 3 by again 1. So we have frequency of 1 is 1, and frequency of 3 as 2. And this is a leaf node, right? So we need to check if this path is a valid path or not. So we can see that there is only one I such that frequency of I is odd. So this is a valid path. Now we go backward in backward direction. So we will decrease the frequency of these 3. So now frequency of 3 is 1. Then we will go to this node and increase the frequency of 1 and make it 2. I'm assuming this is 1, right? So this is again a valid path. Right. Then we will go back, decrease the frequency of 1 by 1. So the new frequency is 1. We'll go again back, decrease the frequency of 3 by 1. So the frequency of 3 is 0. Go in this direction, increase the frequency of 1 by 1. So this will be 2. And again, go in this direction, increase again the frequency of 1, sorry. Now the frequency of 1 is 3, frequency of 3 is 0. So again, this is a valid path. So yeah, we will use our answer by 1, right? And I am assuming this is 4. Taken this is right. So yeah, that's it. Let's code it. So first of all, I'm creating a frequency array of size 10 is 0. So that frequency of I, number of times I here in given path, right? And initializing each and every one with 0. And let's suppose return solve root and frequency. Let's do the solve function the root and the frequency. Now if root is equal to there is no path for returns, there is no value path, right? Return 0. Now increase the frequency of root value by 1. Now let's check if the root is a leaf node or not. Check if root is a leaf node or not. A node will be a leaf node if its left child is null as well as its right child is null, right? then we need to check if this path is a valid path or not. Okay, we will do that somehow. And after that, what we do is, if root node is not a leaf node, we need to solve for root car left and as well as root car right. Frequency, solve for root car right and frequency, and we need to add both of these. And now we are going backward, so we will subtract this root value frequency, and again we will. Now, if the current node is a leaf node, we need to check if the frequency is valid or not, right? If is valid frequency, well, is valid frequency, will give us check basically one and a let's say bool is odd is equal to false. So is odd will be true if there is an I such that frequency of I is odd. Okay, so let's check if frequency of I is odd and is odd is also true. It means there is already I occurred previously such that frequency of I is odd for that. And now again frequency of I is odd. If it's is odd is true, it means there is already a j such that j is less than I and then frequency of j remainder 2 is not equal to 0. And again, we have again find an I such that frequency of I remainder 2 is not equal to 0. It means there are two I such that frequency of I remainder 2 is not equal to 0. We need to return false. This is not a valid path, right? Otherwise, we make this odd to true. We have encountered a I such that frequency of I is 0. And if everything goes fine, we will return true. So yeah, and we need this is the leaf node. We need to subtract again this frequency of root value, and we will return its values. If it is true, we will return okay 1. There is one possible path. If it is false, so we will return 0. There is no possible path. Right? Let's run this. That is accepted. Now there is one more solution. So instead of checking every time for every leaf node if the frequency is valid or not, we can maintain a counter. We can maintain a counter which will store basically number of I such that frequency of I is 4. So what we can do is basically definitely it will not gonna to impact our time complexity much, but yeah, it will make our solution a little bit better. Or is 0, let's suppose, right? As of now, we don't have any I such that frequency of I is 4. So we will take this off. Now what we will do is we will check if frequency of root value remainder 2 is equal to 0. What does that mean? Our frequency is even now. Frequency of root value is even now. So previously it was odd. That's like, what is the previous value of frequency of root value? Is 1 is odd. Then only it's converted to even now, right? So what we will do, we will subtract our odd. Otherwise, now the frequency of root value is odd this time. So we will increase our odd pointer by plus 1. Now, if it is valid only, we need not to check for this value frequency. We just need to check it if our odd is less than or equal to 1. Basically, odd is storing the number of indices I such that frequency of I is odd. And every time we are either decreasing our odd or increasing our odd pointer based on the fact that our frequency value is odd or even. And we need to pass here this code as well. Yeah. So in this scenario, we need not to write this function. And we need not to check for every leaf node. We need not check if it is valid or invalid. And again, if we are subtracting this root value, again we need to do this now. Which is going to is if odd is less than or equal to 1. Yeah. Now I need to subtract this, so I have to do this again. So if frequency of root value remember to is equal to 0, means it is even this time. Previously it was odd. I will subtract all time. And I will return this value. Yeah. So this is basically we need not to check for every leaf node. We need not to check that our frequency array is valid or not. We are just keeping this odd pointer, which will store at any moment of time the number of elements which are the number of indices I such that frequency of I is odd. And we need to change this pointer based on the like if we are changing the frequency array, so we need to change this odd pointer, right? So initially, let's suppose our frequency. Let's suppose the root value is 5, right? So and frequency of 5 is 1, right? Now after increasing the frequency of 5 by 1, now the new frequency of 5 will be 2. So initially there the frequency of 5 is 1. So our old value will be decreased by 1, right? So that is what I'm checking. So if frequency of root value remainder 2 is equal to 0, I will decrease my old value. Otherwise, I will increase my old value. And similarly, again, I'm modifying this my frequency array. So again, I have to modify this odd pointer as well. So yeah, that's it. Thanks for watching and do subscribe my channel. I will try to post daily LeetCode challenge.